In question A, 7 power of something. And then say that we have to express this item in terms of E. A very important thing is we need to create E. It's okay. Then we need to think about what is its opposite. Opposite is natural log something. So it seems like positive, opposite is negative. If there is a number 3, if I don't want to change its value, and if I plus 5, I need to minus 5 immediately to avoid any value change. So similar reason. If there is a number 3, let's say, and then if I create E part of something, then I need to perform exactly the opposite immediately. So it will become like this. We have to perform E part of something and log something in the same step. Of course, you may change the order. Maybe you can log something first, and then what inside is E part of something. So this also gives you 3. So in order to express in terms of E, we have to write E part of something and then immediately log that something. And then we just copy down the whole thing here. We have 7 part of negative 1 over natural log 7. Then this is our 3 layer, first layer, second layer, the third layer. And this is 7 part of something, so we can modify this part and move the index to the front. Negative 1 over natural log 7. And then both right hand side left is natural log 7. And we find that natural log 7 divided by natural log 7 give you 1. So to simplify, is E power of negative 1. Rather than the technique, I want you to learn about the rationale behind. It may be useful in some part later on, but now they're asking another thing. We have to, by considering differentiators, we have to integrate this one. So it's a very typical idea. Just differentiate first. We have to apply product rule. So differentiate the first factor, x give 1, and then keep the second factor. After that, we keep the first factor and then differentiate the second factor. This one you have to remember the rules. 7 part of negative x unchanged, but we have to multiply natural log 7. And don't forget the chain rule, we still need to differentiate negative x. That's why it's keep negative 1 here. Tidy up a little bit, we get this item. To conclude, that means if you differentiate this, they will give you this one. In reverse, if you integrate whole thing here, it will get back what inside. It's because differentiate and integration is opposite function, or what we call inverse function. And then now, they ask you to differentiate this only. So our mission is this integration. This item we don't know how to integrate, but we know that if we can build up this item, then we can integrate it by the results here. So that's why we compare what is difference. What we need is negative natural log 7. So avoid changing value. We multiply negative natural log 7. At the same time, we divide it by natural log 7. Because it's a constant, so we can take it out. We have negative x, 7 part of natural log x, and then natural log 7 at the back. Compare again, only this term is missing, so we try to add this term. At the same time, we minus this term, avoid value change. Don't forget a bracket here. So therefore, we can just focus on the first two term form a group. We have negative 1 over natural log 7, and then our target. And don't forget, when you take out this one, we also have this factor, so it will multiply it and give you 1 over natural log 7, and then 7 part of negative x, oh, it should be negative dx. Then we may just continue. This part is constructed as exactly equal to this part. So the reverse, that means integrate of this thing will become what before differentiation. So this is whole thing is x, 7 part of negative x. And then at the back, 1 over natural log 7. Beware that the index negative x is not exactly the same as x here. So we have to multiply negative 1 and change what inside the differentiation become negative x. Now we ensure that the index and the variable here are exactly the same. Then we can apply the rules. It gives you negative 1 natural log 7, and then this is 7 power of negative x, but we have to divide by natural log 7. This rule is just opposite of when you differentiate this, you have to time natural log 7. In reverse, that means you have to divide by natural log 7. And then don't forget it's not finite, so you have to write down plus c. Therefore, we get the final answer. Part C, they say hx is this item, and then they say after differentiation, when it's equal to 0, only one root fulfill the requirement. So they are talking about h prime x equal to 0. Based on our calculation, h prime x that means this item, so we just write it down. They say only one root for this equation, and then we just try to solve it. And we know that that one will be alpha. I try to multiply 7 power of x on both sides because that is not 0. So we have 1 and then minus x natural log 7 equal to 0. So therefore alpha is equal to 1 over natural log 7. Finally, we have to express this one. That means we are talking about 1 over natural log 7, 0 here. But for simplicity, we just keep using alpha before the final step. So they are talking about alpha 0 and then x 7 power of negative x dx. Integrate this part is exactly the same as what we did in part B, so we just directly use the answer here. But I really hate fractions, so I'm going to extract negative natural log 7 bracket square out from this expression. Then we have x 7 power of negative x natural log 7 in the first term, and then the second term we have 7 of power of negative x left only. And then alpha here is that means 1 over natural log 7. So simplify it, and also don't forget this is what we handled in part A, so we can just replace it by e power of negative 1. And then minus 1, don't forget the last term. So we have negative 1 over natural log 7 bracket square, and then e power of 2 times of e power of negative 1 minus 1. If it's not that good looking, then you change it to 1 minus 2 e power of negative 1. And then finally, I don't want negative index, so I both sides times e. E minus 2 and then e natural log 7 power of 2. But I think this is good enough to get the final answer mark.